Excellent. Okay, well, hello everyone, and welcome to another meeting of the Australian Sensitive Data Interest Group, or AUSDIG, as we call ourselves. So today's session, I'm sure is going to be very informative, but also very entertaining, called Where Did Data Come From and Other Difficult Questions Your Children Might Ask. And our guest presenter today is Ben Harrap from ANU. So before we begin, I'd like to acknowledge the traditional owners of the lands on which we meet today and pay my respect to their elders, past and present. To me, that is the Whadjuk Noongar people. Indigenous data is often sensitive data. Historically, Indigenous data has been used in the systematic oppression of Indigenous people at the hands of colonial and state powers in our country's history. I've been taking every opportunity to educate myself in cultural competency, including the challenges of learning the truth about Australian history since 1788 and the use of Indigenous data in the foundation of the modern Australian state and its institutions. I'm better prepared to work in partnership with Indigenous colleagues on the governance of their data because I'm open to learning and growing a deeper understanding of these issues. In acknowledgement of our Indigenous communities and deepening our commitment to respectful engagement with Indigenous people and their data, I would like to invite you to also interrogate this history and deepen your knowledge on these matters. And on that, there was a documentary released on SBS On Demand just on Monday. It's called Genocide in the Wildflower State. I actually saw it at a screening here at Curtin University just last week. It's a truth-telling documentary about stolen generations here in WA. Fantastic to watch if you want to learn a bit more about stolen generations. So, yep, look it up on SBS On Demand. So that leads us, oh yes, there is a recording in progress. You would have seen the notification come up hopefully. This will be published on the Sensitive Data YouTube channel. So if you don't want your video to appear, you might want to turn the video off. I will stop the recording when we get to question time at the end. So yes, I am going to hand over to Ben to talk about where did data come from and other difficult questions our kids might ask. And then we'll be referencing the Mayi Kuwayu Study, which is about Indigenous data. So all very nicely connected. So over to you, Ben. I'll just stop sharing.
Thanks, Carly. Thanks for the opportunity to come and do the talk. It's going to be, yeah, like you say, hopefully informative and interesting, and it will have some silly parenting jokes that are largely front-loaded at the beginning. So if you don't find them funny, I apologize in advance, but they won't be persistent for the entirety of the presentation. Yeah, so I really enjoy working with data. So I wanted to do a presentation on, I guess, data cleaning and how we arrive with cleaned data sets. I feel like a lot of researchers tend to maybe take for granted the data sets that they get to work with without thinking too deeply about the, can everyone make sure they're muted, please? I'm getting a little bit of feedback. Joanna, I can see you're not muted. Yeah, I feel like researchers take for granted data sets that they get, maybe not all the time, but even things like data user manuals don't tend to go into the real nitty-gritty nuts and bolts of what it takes to arrive at a clean data set. So that's kind of what this presentation is about. I also just wanted to acknowledge that I'm zooming into you guys from the lands of the Ngunnawal and Ngambri peoples and pay my respects to the elders past and present, and yeah, express my gratitude for their continuing care for the country that I get to live and work on. Just a brief little bit about me. As mentioned before, I'm working on the Mayi Kuwayu Study and other projects as well, but the Mayi Kuwayu Study is my main focus, and that's at Yadurawalani, which is a centre here at the National Centre for Epidemiology and Population Health at ANU. And I've been doing stuff with data since 2017, fairly early in my career, I guess, but I don't know. it's what I love, and I feel like I found my calling in life. And I've worked with data from all sorts of different contexts and different study designs, as you can see listed here. So different exposures, I think about it a lot, and all my different experiences with these different types of data sets have been actually quite useful in what I do now, which is mainly data management, some analysis, some research with the Mayi Kuwayu study, which is, if you're not familiar with it, the largest study, national study of Aboriginal and Torres Strait Islander culture, health, and well-being. And I feel like it's really important to stress the culture part. You know, there's quite a few large surveys out there, like the National Aboriginal and Torres Strait Islander Health Survey run by the Australian Bureau of Statistics, but that tends to focus solely on health. There's not a lot of information in there about culture, not even be any now that I think about it. And culture is a really important part of understanding health in the holistic context, as well as well-being. And the study itself, the first wave starting in around 2018, wrapped up late 2021. We have about 12,000 responses to that wave, and we are currently at the tail end of the second wave. The questionnaire itself, we make available in both paper and online formats. The majority of our responses, though, do come back via paper questionnaires. As Kai was talking about before, just referencing Indigenous data sovereignty and governance, that's really the first principle and foundational building block for the Mayi Kuwayu study. We have Indigenous data sovereignty front and center when we're thinking about how we manage our data, how we analyze it, what kind of research we do. And there are Indigenous data governance processes that, I guess, encapsulate all those things as well. And recently, the study won the NHMRC David Cooper Clinical Trials and Cohort Studies Award. So obviously we're doing something right. I've only been part of the team for the last 12 months, I should add. So there's a lot of other people. It's a massive team that's been working on this for many years now. So just to get to having a clean data set that researchers can use, we have to start off by getting data. And I have a 2-year-old, and he didn't really, but I can imagine him saying to me, "Daddy, where did data come from?" I hope one day he asks me that question, because I'll be delighted to tell him. And it starts off with a conversation about birds and the bees, where several consenting adults get together and decide to make a questionnaire. That's what they decide to make. You have to start off with a method of collecting your data. And once you've got this questionnaire, you need to do a bit of piloting and testing with it first. So you show it to some people, they might give you some comments. You know, it's a bit tall, the question is too long, maybe we need to cut it down. So very interesting output choice. There's maybe some design issues with the questionnaire that need to be addressed. Oh yes, they're gorgeous. They're perfect questionnaire, good to go. And it looks just like you. I'm not really sure what that means, but now we've got our questionnaire. It's time to collect the data. So like I said, majority of the data that we get back is paper-based questionnaires. It's 16 pages long. We mail them out and they get sent back to us. So the first iteration of the study, the first wave, was a sample of the Medicare database and also recruitment through referral, snowball sampling, collaboration with community partners as well. And something that I think is really clever that we do in terms of distributing the questionnaires is send people two. So one for them to fill in and one for them to give to a friend or family member. And I think that's really effective at getting that snowball sampling kind of mechanism happening, because it's all well and good to ask people to tell their friends about it, but it's even better if you can give them the actual questionnaire to fill in and send back. The other method, obviously, is via electronic mail, or as the kids these days call it, email. So currently for Wave 2, we will redistribute the latest iteration of the questionnaire to our past participants. We also have a newsletter that people can sign up to that will, prod people to partake in the questionnaire. We also have some presence on social media. We also will have booths at conferences. So if there's any Aboriginal and Torres Strait Islander people at a given conference, then they can come and learn about the study in general, but also we have the questionnaires there in case they also want to participate. And I mentioned before, we also do a lot of community engagement. So that's partnering with community organizations it's a reciprocal relationship that we end up forming. So we collaborate with a community partner to understand what their research interests and needs are. We do data literacy training, and part of the relationship is that they also will distribute questionnaires and do some recruitment in their local area with the community that they work with. So we also have a roadshow happening right now, which I think is really cool. So one of our staff members, Kirsty, is driving around. I think she's driven from Queensland all the way across to the north of Western Australia. And we'll be doing a bit more driving to just get out and meet community partners, because it's much easier to get engaged with people when you've got someone in front of you rather than cold emailing, you know. So we've got all these different mechanisms of collecting the data, which is great. So now we've distributed all of our questionnaires, sent them out into the world, and now we start getting paper copies back. And I liken the story of when we first started getting questionnaires back to having drawings on your fridge. The first one comes along, you're very excited, you pop it up in the fridge. There it is, more appear, more drawings, fabulous, let's stick them up. Oh my goodness, when are the drawings going to stop? Obviously, we don't want the people to stop responding to the Mayi Kuwayu questionnaire, Mayi Kuwayu study, but I really enjoyed being told about the sheer volume of boxes of questionnaires that would be coming in from Australia Post, just wall to wall, floor to ceiling questionnaires that needed to be entered into our data system. Now, much like the drawings on the fridge, every response that we get is retained and stored somewhere, but not like drawings on the fridge. Sorry, no, much like it. Anyway, every drawing is precious, but we don't keep every drawing on the fridge, but we do keep every response that we get. So now that we've got these questionnaires sitting in the office, it takes a little bit of time for us to enter those questionnaires. Okay, the questionnaires have been entered. And then we've also got our online response platform. So we need a platform. We use RedCap. It's the logo there. We use RedCap because it allows us to design questionnaires and implement them, administer them digitally, collect responses. It's pretty decent for data management, but something to think about when you're implementing what was initially the paper questionnaire design in an online platform is that the online distribution of that questionnaire changes things. It changes the quality of the data. So, for example, you can't have people say that they don't smoke and also then write down how many cigarettes they smoke a day. You can control which questions are shown depending on responses to earlier questions. Really great. Reduces the amount of data cleaning, improves the data quality. Also, when people are doing the questionnaire online, it just goes straight into the data platform. So there is less work involved in getting those questionnaires or the responses to the questionnaire digitized. The downside is that for very long questionnaires, it's much easier to stop and a bit harder to return to when you are halfway through a fairly long questionnaire and you go, I haven't got time for this, I will leave. And that ends up resulting in less data. So we might have a whole bunch of responses via the online platform, but a greater proportion of those have missing data and people stop responding because, yeah, it's quite long. The nice analogy that Faye, who's one of our data team, has is she calls them coffee table questionnaires. So people might, with a physical copy, have a bit of a go, fill in some of it, and then leave it on a coffee table. And maybe they'll come back to it in a couple of weeks and do a bit more. And the theory is holding strong that this is how the paper copies tend to get filled in, because we might mail somebody a paper questionnaire and then 5 months later it comes back. And it could have just been sitting on their table for 5 months as they were picking away at a fairly lengthy questionnaire. So online responses, we don't have to wait, actually. They're already in the system. So then we are faced with our paper questionnaires still. So now Billy's asking, Daddy, how do you turn the paper questionnaires into numbers, letters on the screen? So we use a scanner with a digitization, with a software that I guess recognizes, using like OCR technology, what the characters are on a screen. So I've got here a clip of one of our test questionnaires that we use to test out the form and test out the way that the software operates. So the first step in this process is the computer gets to have a go. So it's pretty good picking up checkboxes. Tick, we like that. Radio buttons, tick, tick. Oh, that's a problem because you're only meant to tick one radio box, right? Or one radio button. And then handwriting, how does it go? Not great. So it tries its best, the computer gets to have a first pass and it gets everything in some form or another in the software for then a human to have a go at reviewing. So the main goal here is to check what the computer has identified, fix any mistakes, and there's usually a reasonable number of them, and enter the handwritten text, because by and large, it does a fairly average job. Really depends on the handwriting, to be honest. Some people are very good at writing precisely in the boxes, in block capitals, and those work pretty well. But in all other instances, it falls over a bit. So if you think about entering questionnaires, it takes time. So on average, say it takes about 10 minutes to enter one questionnaire, 16 pages, so it's a lot of content to get through. So you might be able to achieve 6 per hour if you're just smashing through them. And maybe then you do 20 questionnaires a day, because we are humans after all, and we need to have things like coffee and lunch and a break, and maybe not do the exact same task all day every day. So maybe you can get 100 questionnaires done a week. So now imagine having 10,000 questionnaires to get entered. That's like at least 3 days of work, right? So we have to have a lot of staff on board to do that. But it's important because we need to make sure that the data, at least at the entry phase, is as accurate as it could be. Then our humans, they have another go. And this doesn't happen immediately after that first step. This happens a bit later in the data cleaning process, and I'll get to this. But we have this data auditing process because it might be that the scanner has done not a great job of picking up the correct boxes or the correct text, and it also didn't get picked up in the human review process. So at the cleaning stage, these sorts of things will get picked up and they'll get returned into our data review system for auditing, and then humans will go back and refer against the scanned questionnaire. And I can't stress the importance of having a digital scan of the questionnaire to easily refer back to when you're doing this audit process. We also have this process around figuring out why addresses might be unmatched, because we do some data integration too, which I'll talk about. So in this auditing process, they'll check the response which has got the issue and enter the correct value, which in some cases might actually be no value. And finally, thinking about online responses again, no one has to have a go with those. We kind of just accept them as they are. They're already digitized by the people doing the response online. So now it's time for some data cleaning, which is the fun part. And at this stage, we've given the data a bath. So this is a very bird's eye view. It's not actually this simple, and anyone that's done any kind of data cleaning kind of understands that it's not this simple. So we've got our paper and online responses. They end up going into our drawers in the REDCap database effectively. From the REDCap, we're able to extract the data, do some pre-processing, do some cleaning, integrate some external data, and we finally have our clean data set. Janie Barrow, would you mind muting yourself? Thank you. So the first step is having the data dictionary, and I can't stress how important it is to have good metadata or a good data dictionary. So the reason for this is it helps with the data cleaning tremendously. So there might be some cleaning that you do where you want to split your data by the type of information that it is. So that could be numbers, dates, and so on. And having a data dictionary like this, where we've got, you can see this type column here, and we've got the variable names here, enables us to do some coding in a way that instead of having to hard code values into our data set, we can actually use the data dictionary as we can write code as almost like a template, and the data dictionary fills in elements of the template to then apply cleaning code. I think of a little example here, and yeah, cool, it's showing. You guys can see the code on the screen, right? Yeah, nice.
Yes.
Cool. So this is a little example, and apologies if some of you don't write R code. I will just step through this. But basically what you might be doing in this case is you're doing a certain function or executing some code across some variables or columns in your data set. And the columns that we're going to be doing this on are any of the variables from our dictionary, which are numbers or integers. And for these columns, we can then iteratively extract the minimum and maximum values. So you can imagine with age here, we would be extracting the minimum of 16 and the maximum of 130, say. And then we can do this sort of check to make sure that our value of X, which in this case is going to be our age variable, is just between the minimum and maximum values. If it is, leave it as is. If it's not, we use informative missing codes here. So we might assign this -7's value to indicate that it was outside the allowable values range. So this is just a little example of how you can try and write generalizable code that can then pull information from your data dictionary, which is also really useful if you want to transport that code to a different context where the data are different, but you can provide a data dictionary to, I guess, feed into this generalizable code that you've written. The other advantage here as well, by the way, is if you have to make changes to your data dictionary, or rather, if you need to make changes to those, say, minimum and maximum values, changing them at the dictionary level is much easier to then have those changes propagate through to all of the different areas of the data cleaning that you're doing, rather than having to go and find all those hard-coded places where you've written in those things. So a bit of a closer look at some of the steps involved in the actual cleaning. So we've got online and paper responses. We do a bit of pre-cleaning to harmonize them, stick them all together into one big data set. Then we're going to incorporate the data audits that we've got, because we run this data cleaning pipeline, I guess, iteratively to make sure that once there's new audit data, it gets incorporated. Then we've got our data set that's ready for cleaning. We split them by the different data types. We integrate some external data, and then we end up with our clean data set. Okay, so in terms of pre-processing, we've got to do a bit of preparation before we get in the actual bath. So see, reading in the data is a fairly basic, simple first step. Then there's this harmonizing data that we need to do. So you can imagine it as you've got the online data in one object in your environment, you've got the paper data in another object, and they're not quite the same. So it could be that some of the variable names are not identical. There could be minor differences. There could be differences in how variables are coded. And this is just a feature of being a human and doing research, is that we just have human errors that we can pick up at the data cleaning phase. So it could be that in the online version, yes and no are coded as 0 and 1, no is 0, yes is 1. And in the paper version, the software has decided that yes is 1 and no is 2. So we need to do a bit of recoding of these instances where they're not consistent to make sure that when we do join all the data together, that it is consistent. So when we do get to the cleaning rules, it's in the correct format to be validated and cleaned. Then there's also applying any exclusion criteria. So it might be that we've scanned a questionnaire couple of times by accident, just making sure that we're keeping a single instance of any response and removing any of the duplicates. There's also the problem of when people go online, as soon as they submit any information, REDCap's automatically recording and keeping track of the responses as they go. So you might end up with someone who's opened up the questionnaire, filled in maybe their name, and then gone, never mind, I don't want to do this. So what you have in your data still is a record where there's just a name and nothing else. And that's not a useful row for the final clean data set. So we're going to exclude something like that. Then, like I said, we incorporate the audits. So by having the audit data separate, we're never actually overwriting or modifying the original raw data, which is really important for, I guess, like auditing and, you know, looking back over how data has been changed. So at this stage, we've now got our raw data, and we are looking at we're just updating any of the values which have got audits attached to them with the actual value of the audit once the humans have looked at it. And then finally, it's time to get cleaning. And the way that I've set up the cleaning in the data cleaning pipeline for the Mayi Kuwayu study is basically this sort of stepped process. So we have some rule or some set of rules. Well, no, it's one rule. So rule A here might be, well, I'll show you some examples, but basically we do a rule. And if the observation passes the rule, then it goes to the next step as the output. And if it fails the rule, then we do some kind of cleaning, and then it proceeds on to the output. So it could be that the scanner has interpreted number 8 as the letter B. So it might convert all B's to 8, for example. And then the next rule is applied, same deal, passes, goes to the next stage, fails, applies some cleaning, goes to the next stage, and so on and so forth. So there's this, I guess, regimented stepped approach to doing the data cleaning, which has a reason, and I will get to in a minute. I mean, also, that's just how you have to write code. So I've got some examples here, which, again, this is the nitty-gritty of data cleaning. So can you count to 0, 1, 0? Maybe. This is just some examples of how we work with, or how I work with numbers. So at this stage, everything is a string, by the way. Really important to start off from that premise, because when you're reading in things like telephone numbers, obviously it's going to truncate the 0 from the beginning of a mobile phone number, which means you no longer have a valid mobile phone number because the 0 is missing. That's an important feature of the number. So we start off by tidying up any white space in these strings. We remove any audit text. So for example, if the scanning software has entered a 1 when there's actually nothing there, we'll have, for example, the word blank written, and we'll be able to flag that because we write it in a particular way that lets us identify it, and then we remove that. Then we would make sure that our numbers, which are currently strings, don't have any non-digits in them. And then we need to make sure that they actually have digits in them. And then if we're doing integers, we need to check for decimals. And then finally, we need to check that it passes as an integer or a number. So I hope you all love regular expressions, because that's largely my life at this stage. So it would just be doing something like remove all spaces from our string. Very simple. In terms of the audit text, we would be removing anything between these curly braces. And this has been no one writes by hand curly braces, and no one online also uses curly braces. People will use round brackets or square brackets. So this is how we tend to identify the text. So that instance of blank being written between the curly brackets would get removed. Then we're doing something like this, where we are looking for anything that's not a dash or a digit or a dot. Then we're looking for at least 1 digit, because if there's no digits, then there mustn't be anything there at this stage. Then we are checking for decimals. So if we're working with integers, so we need to round it up. Fun fact, if you're an R user, the default round function in R uses bankers rounding, which rounds to the nearest even number, whereas you need to use something like the round half up function from the janitor package if you want to round 0.5s up. And then finally, just checking whether or not our response actually successfully converts to an integer. Cool. Then we've got dates. So first of all, we check if the scanner struggled with scanning. Then same deal, checking for non-digits, making sure that there are separators, checking the values of each element of the date string, and then checking for ambiguous dates and checking for missing days. So in terms of what this looks like, in terms of whether the scanner struggled, so this little hat symbol is something that our scanner will routinely put in when it knows that there's something in the box, but it doesn't know what it is. So that's a really useful heuristic for identifying things that need to be audited. Again, non-digits, no problem. Separators, so if someone has just written the year 2025, that's not useful to us as a date because we need the rest of the date. So if there's, well, we just need to make sure that there are separators between the elements of the date to make sure that we've got all the pieces. Then we want to do something like this where we are making sure that each element of the date is a valid number. So for example, if someone's written 08, maybe the scanner's accidentally flagged that as 00. So we would be doing a function to have a look at what the minimum value is. And we want to make sure that the minimum value isn't 0, because that's usually indicative of this, again, the scanner having had a hard time. Then there's ambiguous dates, and this is like a really necessary step for the following step. So here we're just making sure that a date which is missing one of the components, if it passes as a day month and it also passes as a month year, it's ambiguous which one it could be. So it's kind of difficult to know what to do in this scenario. And in this step here, what we end up doing is picking a random day of the month for when we can guarantee that the date is actually a month-year format, because you don't want to pick just the middle of the month or the first of the month, because if you are doing that for lots of missing days with your dates, you artificially reduce the variance when you're doing things like longitudinal analyses and time series stuff. Then there's things like working with strings. There's a lot of things to check. So again, standardizing them, which is just doing something like removing all the white space, condensing it to a single white space. I've learned a lot about Unicode in the last few months. There's only so much that the regular expression for white space can pick up. For some reason in our data set, there are white spaces which are Unicode characters, which are also not flagged as actual white spaces in terms of a regular expression. So we have to be able to pick up and flag those and remove them. Then there's checking for empty strings. Again, if there's nothing left in them, then, well, we just set them to missing. Again, oh, I've got the wrong text in there, but you can, yeah, did the scanner struggle? Has it got that little hat symbol? Great. Then there's something like this where I'm really grateful actually for hallucination becoming a popular word to describe poor performance of large language models, because I feel like it's also a useful thing to explain what's going on with the scanner. So speech or language impairment here is actually a tick box response option from the line of responses above where the free text box is. But because the scanner got misaligned, perhaps, it's actually entered this text here that's from the free text box above, sorry, from the checkbox above into the free text. So things like this. Oh yeah, and then this is just doing something like looking for numbers and letters. So if there's, I can't remember what this is about. Anyway, then there's things like unusual characters. So this is a wonderful regular expression. And this is basically looking for words, digits, and common symbols that people use. So if there's anything in a free text box that is not something in this list, flag it for review. Because again, the scanning software quite often will just find stuff that isn't actually there and make things up. And then there's specific formatting that you can use for certain variables. So make sure that your email follows an email format, make sure that your postcode's got 4 characters, all those sorts of things. So then, now that we've done our data cleaning, we are going to do a bit of data deriving. So using the existing data, we might derive some new information that makes the final clean data set more useful. So on our back page, we've got an entire A4 sheet of paper, basically, where people can write whatever they like. And from that, we'll do some transcription of the actual handwriting and code it into topics. So people wanting to do qualitative research have a list of topics they can look through. Then, obviously, being a survey, we calculate survey weights, post-stratification weights. We calculate some standardized variables so people can respond to questions in all manner of ways. And we want a standardized way of using things like age or gender or something like that. So commonly used demographics. So one example, there's also validated measures. So things like the K5 measure of psychological, is it distress? Yeah, something like that. So rather than leaving our end users to calculate these things themselves, we do it as part of the data cleaning process. So everyone has the same version of that variable. Then we also do some incorporation of external data. So people provide us with their addresses, and with those addresses, we can match to the national, I forgot what the G is, the national address file, which is provided by Geoscape. If you've not heard of Geoscape before, or the GNAV file, I highly recommend you look into the services. It's great. They provide free 20,000 free requests a month via their API. So that's enough for us to be able to add things like what statistical areas people's addresses are in, or what electorates they're in, or remoteness areas and those sorts of things. And then from that, we can also incorporate additional ABS data products like Indigenous areas and regions. During this process, we also make sure that we're not resending addresses that we've already got that data for, just to kind of limit the number of times we're sending queries through the API. And then we also do a bit of internal data linkage. So trying to identify repeat responders within a wave, because there's no restriction on how many times people can do a questionnaire. We also do linkage to identify people across the waves and potentially across studies as well. And that's really important for generating a unique identifier. So when people are doing research, if they want to have one person per wave, then they have the ability to be able to do that. So now it's nearly bedtime, but there's a few more things that we need to do. One of them is encode missingness, and I've got a nice example of this in a second. I've also written a blog post about that if you want to have a look. And now we finally convert them into their relevant data types. So everything is a string up until now, and we put it in the relevant date, number, integer format. We do some final checks just to make sure that things are between the right bounds and there aren't any numbers or values that are snuck in that shouldn't be there. We also name our variables, I think, sensibly. Again, another blog post on variable naming, something I'm quite passionate about, is having human readable and usable variable names. And with some things like autocomplete, actually, having longer variable names isn't a huge issue. Then finally, labeling the variables in the data set as well as the values, and de-identifying the data, so removing any identifiers so our end users can use a data set and we haven't got to worry about disclosing, identifying information. So finally, Billy comes along and says, "Daddy, have you thought about using metadata to inform the questionnaire redesign process?" It's a very smart 2-year-old, I have to say. So I talked about missingness before. So there's a few different ways that data can be missing. So if we have this data set here, for example, we've got first name, age, we've got this set of X variables, this set of Y variables, and this set of Z variables. And we've got some responses here. So for Tom's responses here, he's responded to X2 and Xtext, but X1 and X3 are missing. Similarly with Y, we've got a response to Y1, but not Y2 or Y3. So what I would call these is missing at the item level. Then you've got someone like Jenny who hasn't responded to any of the Y questions, and that is missing at the question level. So you can imagine if you've got which medications have you taken in the last month? 20 different options. If no one's answered any of those questions, and there's also a none of these option, then I would say that they haven't answered the how many medications have you taken question. Then there's this kind of missing where Trevor, who has no last name, answered the X questions, but then stopped responding to the questionnaire. Didn't answer any of the Y questions, didn't answer any of the Z questions. This is all missing data, but it's missing for different reasons. And the missing can be really informative as like a metadata item when you're looking at something like the questionnaire redesign. So in terms of other things that we'll look at in like the data about the data, is looking at the invalid responses. So going back to when we've got the rules that we're applying to the data, each of those rules ends up being a column in the data set, which we can check for a true false value to see whether or not that rule has been met or failed. So looking at the outcome of those rules for every single question, we can see which questions are failing the rules more frequently than other questions, and try and figure out if that's to do with how the question's worded. Could be to do with the response options, the context of the question, could be the section that it's in, could be the layout of the questionnaire itself, could be confusing, leading people to, for example, fill in that they previously smoked and they currently smoke, when we were expecting them to just have response to one of those two sets of questions. Again, could be a scanning issue, and there's all sorts of, there's so many different ways that, or reasons that question could be struggling to give us high quality data with that doesn't require much cleaning, and having those rules available helps us look into why. And then the other side of things is looking at the valid responses that we have in our final clean data set. So again, I just went through the missingness, understanding the different types of missingness. You know, are people dropping off after a certain section? Are they not answering the discrimination questions at all? Because, you know, discrimination is unpleasant and it's not enjoyable to talk about it necessarily. So maybe they don't answer those questions. Again, that could be, we could have a look at the response options as well. So this is to do with things like having ceiling effects or floor effects in, if you're using Likert style response options. So if you've got the distribution of responses and 99% of them are all saying not at all, then maybe you haven't provided enough of a range in terms of response options, or you haven't framed the responses appropriately, and you haven't got a lot of variation in that question anymore, which isn't going to be a useful data item. Again, question topic, discrimination, I was talking about that before. So after all that, we finally have our clean data set. We have a bunch of information that we can use to inform the next iteration of the questionnaire. Happy days. We're at the end of the presentation. So it's a pretty big job doing this. So I started working on the data cleaning code rework back in January, February, and it took about 6 months of it being my main focus to go from nothing to having a functioning data cleaning pipeline that incorporated all of these things. It became very clear very quickly that having the data dictionary sorted out is very important. And in the actual code that I've got, there's a several hundred line long script just to make sure the data dictionary is in a correct and usable format. And that again then leads into writing generalizable code. The other thing is looking at the data, and it's really easy to write code that you think does a thing, but looking at the output of what that code's actually doing is really important. And that naturally leads in then to writing things like tests to make sure that the output is in the format that you're expecting it to be in. You can be very strict about that, but still always, yes, look at your data. And that's the end. Thank you, everybody.
Thank you so much for that, Ben. That was so informative. And I must admit, I'm glad I did the R carpentry course earlier in the year. So I stood some kind of fighting chance of understanding those bits of code. I'll actually just stop the recording now and we can go on to some questions.